Solving sine x and cosine x by nesting their Taylor polynomial. Here are the Taylor polynomials for the sine and cosine function. Sine x equals to x minus x cubed over 6 plus x fifth over 120 minus x7 over 5040 plus x to the 9th over 362,880, etc. Same thing with cosine, equals to 1 minus x squared over 2 plus x to the 4th over 24 minus x to the 6th over 720 plus x to the 8th over 40,320 minus etc. The values of x are in radians. Using a simple calculator to evaluate the polynomials, you have to raise x into their power and apply the constant, then store it in memory plus of the calculator. Then move on to the next power of x and to the corresponding constant and so on. It is a cumbersome process and lots of stoppages. I will show the one for sine x, and this is the formula. Sine x equals, factoring out x, sine x equals to x multiplied by quantity 1 minus, the x is factored out, 1 minus x squared over 6 plus x to the 4th over 120 minus x to the 6th over 5040 plus x to the 8th over 362,880. Factoring out of the series, and we stop at the x to the 9th term. Next, factoring out the x squared. Sine x equals to x multiplied by quantity 1 minus x squared over 6. It's factored out, and quantity 1 minus x squared over 20 plus x to the 4th over 840 minus x to the 6 over 6480. Double parenthesis. And sine x, and factoring out the rest, sine x equal to x times 1 minus x squared over 6, quantity 1 minus x squared over 20, quantity 1 minus x squared over 42 plus x to the 4th over 3024. And finally, sine x equals to x quantity 1 minus x squared over 6 multiplied by quantity 1 minus x squared over 20 multiplied by quantity 1 minus x squared over 42 multiplied by quantity 1 minus x squared over 72, and 4 closing parentheses. See, notice that all the terms now are in x squared except for the first one. X squared, x squared, x squared, x squared. So if only we can get the value of x squared and put it into the memory, then if we calculate it, and we only need to input from the memory the x squared value. If you solve that formula backward, then you will have lots of sign changes needed. So this formula can be reversed as, reversing the process, sine x is equal to triple opening parenthesis x squared over 72 minus 1 multiplied by x squared over 42 plus 1, then multiply by x squared over 20 minus 1, then multiply by x squared over 6 plus 1, then finally multiply by x. And similarly for cosine x, and this is the nested polynomials, and the reverse formula is this one. Cosine x is equal to x squared over 56 minus 1 multiplied by x squared over 30 plus 1 multiplied by x squared over 12 minus 1 multiplied by x squared over 2 plus 1. So notice that in the sine value, you have to multiply by x. So what you do is, after you get all those quantity, you multiply by the x squared and then get the square root. Let's try solving sine of 30 degrees. First, we change 30 degrees into radian. 30 multiplied by 3.141592654 divided by 180. And this 0.523 is the radian value of 30 degrees. What we do is we press multiply and memory plus, and you store the x square into the memory. So following the equation, it's equal to x square divided by 72 minus 1 times x square divided by 42 plus 1 times x square divided by 20 minus 1 times x square divided by 6 plus 1 equal. And this value now we're going to multiply by x. So what we do is multiply by memory recall, that's x square, but we press square root sign and then equal. And this is the value of sine of 30 degrees. And solving for cosine of 30 degrees, we do the same thing. What we do is using the same 30 degrees, this one is x square. Following the formula, divide by 56 minus 1 times x square divided by 30 plus 1 times x square divided by 12 minus 1 times x square divided by 2 plus 1. And now that is now the cosine of 30 degrees.